Okay, so this is part 284C3M1b7c8e11b. You want to start with 11a if you're working on this particular bit of data. Line 22f1fa19c3m1b7c8e11b. Olefins, heterogeneous, Markov fuel, UFO, 5G Wow Seti. Here's our alien radio signal, and this video's keywords, inventions, fuel formulas for the UFO space engine. Okay. December 17, 2012. Today's December 26th. The keyword to Google from data is Markovian transport systems. From previous videos continues. There's several videos before this one, okay? So it's actually in the 10s and the 11s. So line 22f1fa19c3m1b7c8e11a Markovian polymers transport formula UFO 5G Wow Seti. Actually, that's true. All of line 22 is basically about transports and fuels and all sorts of stuff. So Google keyword from data, cyclization reaction Markov. So the keyword from a PDF file is Non-Markovian polymer reaction kinetics, and this is a quote. France. Oh, this one's from France. Keywords from that data is transport limited polymer reaction kinetics, and that's from www.ncbi.nlm.nih.gov. Okay, quotes and diagrams from the blog. This is talking about macroparticle and microparticles. So we got your external boundary layer, mass and heat transport through external film, heat conduction, diffusion and convection of species through pores, sorption, equilibrium between fluid and porous polymer, macropores. And then you got all these little number thingies there. Then you got your microparticle, polymer phase, crystalline domain, catalyst, fragment, surface reactions, polymer swelling by sorbed species, crystallization, melting, diffusion of species through polymer phase, and heat conduction. Okay, there we go. Okay, so catalytic polymerization of olefins in heterogeneous reactors. In the gas dispersion example, fluidized bed and liquid dispersion slurry reactors are industrially important processes. The polymer is typically produced on supported catalysts fed into the reactor in the form of particles. 3 spatial levels are considered in the description of liquid and gas phase catalytic polymerization reactors. So we have a fluidized bed reactor and a polymer particle. So you've got your compressor, gas feed, degassing, catalyst injection, heat exchanger, and then you recycle it. Okay? Polymer particles, microparticle, external boundary layer, and macroparticle. Okay? With all the calculations there. Micro scale, complex reaction kinetics, the presence of commoners, dienes, several types of active catalyst sites, branching of polymer chains. The molecular architecture of polymer product can be predicted by population balances of polymer chains, method of polymer moments. Mesoscale, polymer particle growth and morphology, fragmentation of catalyst phase equilibria in the polymer particle, heat and mass transport in the particle. Macroscale, mass, heat, momentum, and energy balances in the reactor, particle size distribution, residence time distribution, heat removal, polymer fouling, macro and micro mixing, non-uniform concentration and temperature fields in reactors. So that's www.vscht.cz. December 17th. The keyword to Google in the next video is heterogeneous reactors. Thanks for watching.